All right, so today's lesson is going to be focused on weldments and surfacing. Let me just edit this here real quick. Sliding properties. It's a little too high. All right, so weldments and surfacing today's subjects. So hopping into SolidWorks here. Weldments is basically how we design what looks like what we see on the screen there, the frame of the car. Key things with weldments to remember is that you're going to have a constant cross section for whatever you're doing. So all these tubes, they're all defined by their outer diameter, or if it's a square tube, or a rectangular tube, the length of the width, certain thickness, and all along that tube it's going to be that same constant cross section. So because we design a lot of these same kinds of parts, instead of having to go through and extrude a lot of stuff and shell and all that kind of stuff, SolidWorks created weldments to make it easier for us to go through and create these complex structures. So we'll go ahead and let me just close out of that. Cool. And swap over to that. Cool. All right. So looking at, we'll just create a new part. The way SolidWorks defines weldments, again, is that constant cross section. So there's actually parts within SolidWorks and sketches that SolidWorks automatically creates whenever you download SolidWorks that has some default kind of profiles for you. And the way that you figure out where those profiles are by clicking on the settings or system options, and then you can go through down to file locations and down here to Weldment profiles. Cool. So this is the default one that you're going to see. And then I have my own folder of additional weldment profiles. So I can actually go ahead and I'll open that up just to show you guys what that looks like. SolidWorks, weldment profiles. So I have a couple of different ones. This is one that I downloaded off the internet. It has most of the stuff that we need in order to design kind of our Formula chassis. It has way more than we actually need. So it has channels, I-beams, L-angles. Really, mostly we just work with square and round tubing, and AI here stands for ANSI inch. And then down here you got some more options. But inside these folders are individual what are called library feature parts. And so each of these is just a sketch that got saved as what we call a library feature part. All that you need to know about it is that it can be accessed by SolidWorks and just dropped in kind of as a sketch tool with a couple of kind of key things like positioning. So we'll kind of get into that once we actually start building some weldments. But each of these is its own size. And once you actually go in, you'll actually see there'll be a drop down where you can actually look through all of these different files. The name of the file is what will show up without the .sld LFP. And I guess just as a kind of more relevant one, we use a lot of 1 inch square. Let's go 065. So you can see there's a square. Inside's hollowed out. 065 in there. And that's one of the more common tubes we work with. You got more of them. They're all squares, just all different sizes of all different dimensions. So that's where they're located. If you ever download more, you can either navigate to this folder here, or you can add in your own folder. That's super important to be able to use weldments. So let's start by creating a simple sketch on the top plane. We'll just make a simple rectangular frame just to kind of get familiar with how SolidWorks does weldments. And actually what I'm going to do is I'm going to switch to inches for this, just to make it a little bit easier to work with. So we'll make like a 24-inch wide. Maybe we're making like a welding cart or something like that to house a welder and a couple other things. 24 by 48, 2 feet by 4 feet. Fairly common size for just getting like an offcut of plywood or something like that to stack on top of this cart. This will be our base. So just a rectangular section. Basically what we're trying to do is have maybe like an 1.5 inch square tube go all the way around, to start off. And all we have to do to create this again is just to create this rectangular sketch. So we're going to exit out. And then up here, it looks like I don't have a Weldments toolbar yet, so I'm going to right click on any one of these tabs, drop down to Weldments, click it in, and now I can go to my Weldments tab. So see, SolidWorks dropped in a couple of things that tend to be fairly common to use with Weldments. So 3D sketches, which we'll get into in a little bit, the weldment itself, structural member, boss base, and a couple other options in here which are grayed out. But this weldment button off to the left here, it's kind of a useless button, to be honest. All it does is it drops in this little weldment feature here, and with that, it kind of sets up a couple things, just telling the program, hey, we're doing a weldment, or we're creating a part that's going to be using weldments. It's kind of redundant because once we hit structural member, it automatically, if we don't have this weldment bit created already, it'll automatically add that in. But it's nice to tell SolidWorks, hey, we're working with weldments, so let's go ahead and create a structural member. So in the standard folder, if you remember, that's kind of that first folder name. Let me pop that back open, actually. So SolidWorks Weldment Profiles. This is my standard name up here. And then my type down here. Let's see, we need square tube. Fancy inch tube, square. And then we'll drop down, I think we said 1.5" tube is what we want to use. So we'll go down here, 1.5", do 0.95 wall. Cool. All right, and now what we do is we add in groups. So groups are collections of sketch lines or 3D sketch lines or curves or anything else that we are using to outline these tubes. So I'll click there. See, it starts to drop in a tube on that sketch line. Click another one, another, and another, and now I have all 4 of my tubes. Cool, just like that. Super simple, created a frame. But we have a few more options. So if I zoom in here on the corners, you can see that right now SolidWorks is butting these tube segments right up against each other. And maybe I want a miter cut instead. So and also if you see going around in a circle, here it's butted up like this. Down here it's butted up the other way. It's where this end tube is going all the way out. So over here, I can switch all of the corner treatments. That's what they're called, kind of the way that everything's coming up to, or kind of the way that the tubes are coming up against each other. And globally, I can switch them all to miter cuts. See, now they're all cut nice 45-degree angle, but butting right up against each other. Super nice all the way around the part. Now, if we go on and let's go back to this butt feature here. So let's say that I actually do want butt treatments on my corners, except I want these end pieces to be the long ones and the middle, the longer pieces to just butt up to them. So by clicking on these little purple little circles that pop up on each corner, I can just click on it and it's going to, hold on. Oh, it's popping up right here. Cool. So corner treatment, I can click on just that corner and switch it over to the other one. Switch to a miter if I wanted to. But basically here I can modify this for each corner. And so just to illustrate that over here as well, same thing. Click, check mark, all done. So now I have my 2 long tubes here, other tubes coming up there, and then I can close out. Cool. Now I have my little rectangular frame. One thing to note here is that I should just top it here again real quick. Noticing my audio is going all over the place. Drop that gain down a little bit. Alright, so one thing to note is that when we added in these profiles, you can see the sketch is right in the middle of it. So if I planned out my sketch ahead of time to be the actual center line of the tubes, that's great. Especially if I have like center line bend radii that I'm using for like a main roll hoop, that's great. But what if this going back to our sketch, what if this 2 foot by 4 foot was actually the outside edge? It's a sheet of plywood that I have that I'm putting on top of this card at the very end. I can actually do that. So let's go back into this weldment feature, and let's see. Yeah, right here. So going down just below the corner treatment, we have this alignment. So let me figure out. Yeah, there's that initial sketch. You can see. Oh, come on. So there's that sketch that it plopped in from that library feature part, and now I have the option to align this a couple of different ways. Locate profile. Sorry, alignment just means kind of how it's rotated, left, right, up, down, or at an angle. Locate profile is the thing that I want. So it kind of pops up. You can see these orange little dots as I hover over the different sketch points, and basically that's where the profile or the layout sketch, I'll call it, is going to intersect the part. So I'll click just the outside edge there, that little point right in the middle of the outside of the tube profile. And now if we look from the top, the sketch is going all along the outside of this part, which is super nice. Again, just with one sketch, we defined this relatively complex, this is a square tube section, but in general, we can define fairly complex structures just by kind of laying out where all those tubes are going to go, instead of actually having to model each individual tube itself. So that's what we're looking at there. You can also apply some materials to this if you want, plain carbon steel. But yeah, now we have a steel section of tube here. So that's kind of a very simple way to look at things. But let's say that this cart isn't just going to be flat. Maybe it's going to go up. It's going to have some shelves on it. So let's get rid of this feature and just go and build. Yeah, just delete that out. I'm going to build a kind of side, or build up some legs coming up off to the side there. So gonna have to make a new plane first. So reference geometry plane. First reference is going to be my front plane, and then second reference is going to be that line, and it's just going to be parallel there. All right, so now I've created a plane that's kind of looking from the side, but it goes through this line here. So I can hop in, and now I can draw a sketch on that plane. I'm going to draw some legs going up. Cool, and maybe I can actually even draw the top of the table here on the sketch too. And then notice I drew those kind of off the side there, just so I can go down here and then add in to make sure that it's actually piercing those points on the end and not something on the front. Cool. And then now I just give this a height value. Maybe let's say it's 30 inches tall. All right, exit sketch. And then maybe I'll need another sketch, something similar. So go ahead and create another plane parallel to that one. Second reference is going to be there, and making sure it's parallel. Default's perpendicular for some reason. Create a sketch. I'm just going to convert these entities so that the first sketch that I created, that's going to be the one that's driving these other ones. So I'll just convert. See, it's all fully defined because the dimensions that I added here are going to be driving the dimensions of this sketch. Cool. Exit sketch, and then I'll make one more plane to finish off the top of the table here. Plane, one line, two lines. Both those lines are on the plane. Cool. Getting a little confusing, so I'm going to hide some of these planes. Get them out of the way. Create another sketch. And kind of hard to tell. Looks like I'm looking at it from the opposite side. But we'll go through. Coincident from there. Coincident from there. Same thing over there. Cool. So now we basically have just a box, right? So this would be the start of our little cart that we're building. Same thing. I'm gonna go back in, structural member. One of the other nice things is SolidWorks kind of saves the kind of profiles that you're working with a lot in its memory. So one of the things that we're going to be doing for the team is we're going to have a folder of all the different kinds of tubes that we commonly use. So you just download that in, always working on the same standard, and then you just pick out your type, whether you're doing square or round tube, and then you pick out your dimensions out of the most common ones so you don't have to sift through all of these. But again, we're working on the same profile or same kind of sketch or same wall thickness. New group. We'll go ahead and select again these bottom 4, and then I'm going to try to select these, but it won't let me. And that's partly because SolidWorks, either wants you to, when you're making these groups of different tubes, it wants either the group to have kind of every single endpoint kind of go around a path, basically. So like if you think about the roll hoop on our car, first straight line, then curve, and straight, then curve, going on that way. Or it wants all the lines to be parallel to each other. So I'll make the new group. All 4 of these legs, we can do all of those in one sketch or in one group. So that's basically just to make sure that in this kind of group, we're applying corner treatment at all of these. On this, it's making sure that since they're all parallel, they can all be separate. We don't have to worry about corner treatment at all. We don't have to kind of interpolate where they're going to cross over. And then one other thing that I want to do, actually we can just keep doing this. So one last group for the top one here. All right. And then one thing to note, you can kind of see this corner here looks a little wacky. The reason being here is that SolidWorks evaluates these groups one after another. So it first creates this one. Then when we add in this one, you can see the corner treatments. It's going right up to there. It's not going through it. And then these tubes already exist. So all the tubes that I'm adding in here in my group 3 are all butting up against that tube as well. The nice thing is though, I can go in and override it. So I can just hop in here. And it gives me what's called a trim order. So trim order 1 means that it's the most important tube. Everything gets trimmed against it. Trim order 2, next order down on priority. If I make it the same trim order, they're all going to get trimmed together with a miter trim because they're all, again, the same. Keep zooming out on me. There we go. Because they're all the same priority. And now if I make this one trim order 2, you can see that this tube is now getting trimmed against my trim order 1 group. And I can, again, I can do all those individually, but the best thing to usually do if I delete that group and delete that one is just to, as you're going through adding them all in, when I make my new group, I'm going to do the next one there. It's kind of standing alone, and then I'm going to make the group that gets trimmed against both of those. Cool. All right, and then if you remember our corner treatments down at the bottom here, so let's highlight that first group. We want this one to be longer, so I'm going to make it that kind of butt joint. Over here, it's that one needs to be flipped around as well. And then in group 5 now, or group 4, same thing. Flip that around, cool. And that's the other one on this one, cool. All right, now we have our cart. We have a 3-dimensional object. The way that we went about doing this is a little clunky. If you remember, I had to add in a plane each time that I wanted to draw in a new sketch, going up, and then another plane on top. And so I have to keep adding in all these planes. And the reason we have to do this is because we're just using what are called 2D sketches. They're the ones that we've been working with so far. They're sketching on a single plane. We can't really make lines going up out of the plane with 2D sketches, but that's where this 3D sketch feature comes in. So I'm going to close out of this and just start up a new part, so I can get rid of all those sketches. And we're going to make that exact same cart, but within one single sketch. Switching to inches before I get started. I'm just going to click on 3D sketch, and you'll notice that it didn't have me select a plane or anything to start off of. That's because I can start drawing lines in pretty much any direction, wherever I want. So start off kind of like we did before with the rectangle. See the origin pops up, and right next to my cursor it says XY, and that means that I'm starting to draw on the XY plane. So looking at my little triad here at the bottom left, see that the XY plane would be kind of the front plane usually, but I can hit the tab key and that'll switch to the other direction. So now it's YZ. Also not the one that I quite want to do yet. So it's X or ZX is the plane that I want to be drawing on. So I will go ahead and start drawing in a rectangle there. Started at the origin, drawing on the ZX plane. And then, if I wanted to add in a line, you can see that if I wanted to have it going up, I'm going to want to switch. Well, I don't want it to arc like that. I just want to hit the tab key. I can switch planes as I'm drawing lines as well. So if I start drawing a line going up, and right now I'm kind of making that back long one there. Boom. Same thing up here at the front. But what if I want to add in that one? It'll dynamically switch them for you too. If you're hovering over a point that you want it to be coincident to, you can see that it goes from drawing a line going this way to just dropping it over there. So it's kind of nice. SolidWorks does do some of the kind of guesswork for you. Right now, though, it does want me to draw kind of along that back face, so I'm going to tab out of that and go this way. And then one last line to connect those two. All right, and you'll notice that everything's kind of skewed because it's very hard for SolidWorks to think in a lot of different directions and kind of match up parallel stuff. So we usually have to go back in and add in kind of those vertical and horizontal stuff at the end. So, we started off with this rectangular sketch. I know that it's, I know that it's going to be along that bottom plane. Really just changing the shape and rotation of it. So what I'm going to do is here now, instead of having vertical and horizontal, I have along X, along Y, and along Z. So this line I want to be along X, maybe. I think, you'll see, perpendicular, got it from the top. I wonder why it doesn't want that. All right. Let me undo my little shenanigans there. So one thing that I will point out, and this is from my experience with working with 3D sketches, is SolidWorks is extra picky with 3D stuff. Again, because it has to solve for a lot of different directions. But I will go ahead and make a dimension here. We had 48 inches that way. And then 24 that way. I think what I'll do is I'll add in a center line. Cool. So this will be along X. And these two will be perpendicular. Maybe. There we go. All right. So we got our 24 by 48, and I can also make all of these parallel, hopefully. Let me just start over here real quick. I was hoping it would all work in one go, but probably your best bet when you're working with Weldments is to define stuff as you go. So we'll go back to the X plane. I'll make that 24, 48, and make the center line. Midpoint and make perpendicular and make long X. Why is it so? Aha, that's why. All right. All right. So SolidWorks, what it was doing there was everything was still underdefined because it could rotate around. One thing that I should add is that everything gets based off of this origin. So that's kind of why it was spinning around like that. I really have to start off from the origin and kind of make this line be along that x-axis and kind of define from there. And same thing with this along the y. It doesn't really add those on-plane relations that it would with a normal sketch. So now we have a base to start off with. We'll go up, and I'm still on the XZ or ZX plane. So I'll go XY now, go along Y, out to here, and there. Make both of these parallel, and this one will go along X. And I just need to add in my other dimension of 30 inches, I think it was. Yep. Cool. And then back to lines. I need something along YZ, another one along YZ, and then the last one to connect those two. Cool. Make all these parallel and equal. Cool. This one. Ooh, this looks like fun. Alright. Okay. Equal length and parallel. Alright, there we go. So SolidWorks are just trying to like really fine tune those last couple of points. But just like that, 3 dimensions, a lot of relations, kind of parallel, equal length, along X, perpendiculars. So you really have to be careful as you're adding in these relations. Really just kind of draw your lines out, add them in, define them, then move on to your next stuff. And also make sure that you're defining from the origin. So here we have that along X and along Y to make sure that our bottom is flat. All right, so going from there, one of the interesting things is there's no exit sketch button up here. It's just in the top right corner for these, for 3D sketches versus 2D. But from here, go back in, create a structural member, same stuff that we were doing before. New group, 1, 2, 3, 4. Apply our corner treatments as we go, so we don't have to go back in later and do that. Yes. Okay, group at the top. And then last group. Cool. Then one thing we forgot to do was to locate our profile along here. So let's go back into group 1, locate, kind of nicely zooms in to that sketch for you, so you have to go hunting for it, kind of figure out which tube you started with. That one's going to get located there. And I do have to do this for each for each group. So I located that one. Now group 2, same thing, locate profile. So me over there. That one, and group 3. This one's going to be different because instead of going along the midpoint of a wall, we're going on a corner. So there's that sketch, and we're going from that corner in. All right, now we should have. Oh, that's kind of fun. So that's something that I just noticed. That's using that same corner on every single one of these, which is great. Let's see, add a feature. I wonder if I can. Group 3. Yeah, so I guess that's something else to keep in mind. So when you're working with that corner, it's going to be looking from the top down, always. Like in this case, the bottom right corner. Each of these points is going to be bottom right corner. So we're actually going to have to split up this group into 4 different groups. So kind of something to keep in mind when we're putting these groups together, or actually putting our sketches together. We want to make sure that when we locate these, down there, we'll just make just that one. And actually what I can do is instead of going through and making a bunch of groups, I can just go through and mirror stuff. So that's another way of doing it. So mirror over front plane, gonna mirror a body, just that one. And then over the right plane, mirror both of these. Cool, so that way it keeps that same alignment, assuming that my part's symmetrical. In that case, I can do it. Otherwise, I wanna make sure, I guess usually best practice is to make sure that you're setting up your sketches usually with the center line of your tubes. That's something like for chassis when we're designing a roll hoop and we have those bends. The bend radius is actually measured from the center line of the tube when you go to send it out to a manufacturer. So, if we have, I think on that chassis we have 3-inch center line radii. So when we're making a roll hoop, we don't have to do all that extra math and go through kind of to offset the tube off there to keep it like along the inside edge of a profile. But yes, that's the basics of 3D sketching. You can you can draw along different planes and stuff like that. Yeah, so that's a start, I guess, but we can go, of course, we can go more complicated if we wanted to. I guess we can try, see how things go. So let's actually try and make a frame, or like just the cockpit area. So we'll go 3D sketch, and then from I'll start, just a couple center lines. Right now we're in XY, so actually I'll make this a midpoint center line. This is going to be my roll hoop width here. And then I will just make sure that this is along X. Yep. And then I'm going to draw in YZ, so this is along Z. This is going to be the length of my cockpit. And then another midpoint construction line at the front for my front roll hoop width. There's the right one. Cool. Make sure, yep, along X, along Z, and along X. So I can kind of start out. And this is what I did when I was designing my Porsche roll cage. I created a bunch of construction lines first, aligned them all, and kind of set my critical dimensions. And so switching back over to inches, because most of the stuff when we're designing it is in inches on the chassis. Start off with, say, probably about 30-inch wide roll hoop, for example, a 40-inch long cockpit, and then a front roll hoop, probably going to be a little bit narrower, so 26. And now I have a fully defined sketch. I can see all my main dimensions, and now let's start drawing up a a main roll hoop. So just making sure we're on XY plane, so yeah, going up. And if you remember with sketches, we can kind of do that. Just hover over the endpoint to draw in a radius. Go up. It's kind of super rough sketch here. Oh, going straight. Line. Tangent. Oh, it's really rough. And then down. Alright, so this one, we need it to be along Y. Merge those 2 points together. Make these two equal. It's going to look pretty wacky. Make those tangent. Actually, what I might even do is just draw like a center line here too. I want things to be symmetrical. Remember, I can do symmetrical relations as well. We kind of covered those before. Maybe not with these. Cool. And these two along X. So one of the things that I do as I'm going through is I'm looking down here at this triad to remember kind of which angle or which which axis I'm going along. Oh, this is another fun thing too. So you can see that as we start to model stuff, it's not constrained in 2D anymore. Cool. Undo that. So this can actually start to bend off to one side or the other. That's kind of one of the tough things with arcs is they're not along necessarily a plane or something like that. So I guess this is a good time to introduce sketch planes. Go through and right up here. So I can actually insert a plane within a 3D sketch to draw stuff onto to kind of avoid what we were coming across there with that roll hoop. So I'll click on that, and then I'll click on my first reference. It's going to be this one. That's going to be my perpendicular, and then I want to have it be coincident with that line. And that should be all that I need to drop in this plane. And you can see everything else in the sketch gets grayed out. And then now I have this grid to kind of work with. So now anything that I draw is just like on a 2D sketch. It's going to be a lot easier to do. I'm going to avoid the stuff that I was doing before. Line. Going down. And then another line. Cool, and now you can see I'm dealing with a 2D style sketch, so now I have these horizontal and verticals again. That one got added in automatically. Join that in, add in my tangent relations where they didn't get added in automatically. We can draw in a center line. Make sure everything's good. There we go. Make sure that center line is vertical. Make these, they're symmetrical. There we go, symmetric relation. And same with these. Cool. And then remember, we're doing center line radius on these, so they're all going to be the same. I don't need a point, just need that arc. So they're all going to be the same radius, so we're going to hit equal. Yikes. That didn't work out. Just go ahead and dimension one of these. Radius of 3 inches. Cool. Alright, let's try that again. All equal. Cool. Alright, and then this I think was vertical already. So now all that's left is to kind of define how high we want our roll hoop to be. 42 inches maybe. Remember, this should be vertical too. And alright, and then let me see, what are we missing here to make this fully defined? These aren't really set to be vertical, huh? That's really weird. Alright, I'll make that perpendicular. There we go. That looks better. So now we add in our side impact structure. You know, that height has to be it's defined by the rules, and I think it's 20 inches or something like that. And then we have our roll hoop height, and then we have our bend radii. So just like that. Kind of the wacky thing there was, even though it had a vertical relation there, it wasn't being perpendicular to this line. So maybe you have to kind of define that initially before you get going. I'm not entirely sure what was going on there, but now we have fully defined sketch, and now I want to go draw stuff out in 3D space. So all I do is I just click escape, I think. Yeah, and then double click out of there. So I got out of my dimension tool first, double clicked anywhere in open space, and now that plane gets grayed out. I'm now drawing wherever I want. So let's go ahead and go through that again at the front here. This is going to be my perpendicular relation for my plane. That's going to be my coincident line. We'll start with a center line this time. I'll define it as perpendicular to that. And vertical, I think. Oh no, I don't need that. All right. Cool. And now we'll make our front roll hoop. This one usually has 4 bends in it, I think. Or no, our one on our last chassis had 3. So actually this time I'll make one with just 2. And super rough, just a couple lines. If we remember our topography that we were talking about before, SolidWorks is treating this, regardless of what these look like, it's treating them all the same. So just need to add in the topography, then we can add in our relations. Make vertical. Parallel. There we go. Now I can define the height of this roll hoop. Maybe our front roll hoop is 25 inches. This is going to be a 3-inch radius again. And because that's a midpoint, it's going to carry over to the other side. Cool. Exit out of that, and now I can add in my side impact structure. So that goes between these usually. Something down below as well. Same stuff on the other side. Kind of start to fill those bits in. Now we usually need a diagonal member there too. Same thing here. Cool. And now we have our chassis. Again, all in one sketch. We have some bends here that are going to happen. And so let's go ahead and try to make a structural member out of this. So roll hoops are usually made out of round tubing. So ANSI inch, round tube. 1 inch 095 is I think what's required on those. So make a new group from here. And you can see we can add in curve geometry. It's not just straight pieces that we use for weldments, curves as well. And then we have this option here to merge arc segmented bodies. What that does is every time that there's this arc, it's just going to create one smooth piece all the way through. We actually want to keep, so we do actually want to keep all that as one part. It's not just going to be a bunch of individual, like a bend piece and then a straight piece, I believe. And then we'll go ahead and make our front roll hoop, because these are the two things that are going to get trimmed against, if that makes sense. So these are going to be the tubes that stand alone. All these other tubes are going to have cuts in them that make it so that they can connect to those tubes. All right, so those are my roll hoops. And then I'm going to actually have to switch to a different tube profile, because I think we use square tubing down here in our chassis. So these are just my two roll hoops. They're both using 095 wall, 1 inch. Got those done, and the 3D sketch stays active, so I can go ahead and make, now instead of that, I'm going to do square tube. Where is it at? There it is. 1 inch. And I think we only use 065 if I remember right on these outside bits. So new group here and here. And they're going to have to be different because they're not parallel. But then one thing you'll notice is that even though these are both weldment parts, SolidWorks doesn't automatically trim against the other ones when they're created in another feature. So anytime you have different tubes joining in together or anything like that, you're going to have to do a trim operation later. So we'll get into that here in a second. And then I do actually want to locate these. As you can see right now, the center line's going through. We want that center line to actually be at the bottom here. So I'm going to locate the profile, bottom there, and same thing with this other one. Cool, so there's that. And then for the side impact structure, I think we use 1 inch, but it's only 065, so another different tube to use. Round tubing, 1 inch 065 wall, new group. So get those two. So they're going to get trimmed against each other up there, but not against the main roll or the front roll hoop itself. And then same thing here. Cool. And they are located kind of where I want them. Now, this is probably all right for us. I think there's a rule where it has to be like within a certain amount of inches from a chassis node when you're joining up a tube for it to count as triangulated. And I think it's like 1.5 inches, whatever your other tube dimension is. So we'll go from there. Cool. Now we have our two main roll hoops. Our lower pieces that we make out of square tubing. I think it's because we kind of mount brackets and stuff to the bottom of those a lot. It's a lot easier to go off of a square tube than a round. But now we have to trim these pieces against each other. So we'll go trim extend up here. Bodies to be trimmed. So this is what we're actually trimming. And in this case, it's going to be these 6 tubes are going to get trimmed. And they're going to get trimmed by this body, or bodies here. That body and that body. So now you see all these little pop-ups kind of come up here, and it shows basically all the different bodies that are made from this. So you don't want to keep this bit here, that little bit at the end. Don't want to keep that at the end there either. Looks like it already is throwing away those other ones. So just make sure, yep, everything else is good there. Cool. And then we can also do either a simple cut or a coped cut here. And in this case, we're not really going to be able to see too well. But basically, kind of on this icon, you can see if you had like a rounded square cube, with a radius on it, either just butt up right to the edge of that profile, or it would actually kind of cut over into there. Usually what we want is actually this. Because when we're welding stuff, we need room for that weld bead to penetrate and kind of bond to the material. If it's kind of right up against it, we're welding on this really tiny, thin piece of metal that isn't actually cut. So we want to kind of cut it flat, leave some room for the weld bead to penetrate in there, and weld to the full thickness of the tube instead of just that little tiny flappy bit sticking off. Cool. So that's one of our trims. And then if you remember down here, this tube didn't get trimmed against that one, so we'll make another trim. Trim these two bodies against these two. Cool, and it removes those for us, automatically picks those out, and now we should have our completed chassis. I'll go ahead and hide that sketch. So zoom in here, there's one body coming in, this body gets trimmed against it, down here gets trimmed flush against this square bit at the bottom, and then our roll hoops are just one continuous body all the way through. Everything's nice and cut through. I can also go in and I think, yeah, so right here, isolate, you can just look at that tube itself. You can see it's cut nicely against that. One thing that does happen here though is we have this little bit sticking out. So this is kind of going back to what we were talking about with the coat cuts and just a simple cut with that trim extend feature. Here, sometimes it might be good to leave this in just when we go to make our manufacturing drawings and like little stickers. I don't know if you guys were around for when we cut tubes last year, but we made stickers that go on the ends of the tube and it kind of traces out this surface here. So when we go and we cut down with the hole saw, gives us where we need to cut, and then we'll go through and hand finish and actually just grind off these little bits at the end. So kind of with that manufacturing process, it doesn't really matter whether or not we keep that. But when we go in, we just exit that isolate feature there. Like with these trim and extend features, you can edit it and I can add in an actual weld gap. And sometimes just adding in even a small weld gap like 0.05 inches, it can clean up those ends a little bit. So again, kind of isolating this. We don't have quite as sharp of a little bit sticking out there. Kind of a little bit more rounded out, gives us a little bit of room. And then if we kind of look in there again, have that gap for a weld bead to penetrate into there, join to the flat part of there as well. So that's really all that there is in terms of weldments that we use on the team. I mean, this trim extend, you can use it not just to trim the parts as it kind of implies, but also to extend them. So if you have if we have this little weld gap that we added in and we didn't want it, just through like a trim operation or something else happened, we can extend. Or no, I guess so. Either way, it's going to, like, if you have a tube coming through, I guess a good example would be here. It's like if this tube, when we made it, it stopped like right there almost. I could extend that tube out further and kind of trim it against this body. So maybe I'll go ahead and do that real quick. How would I do that easily? Just go back in at our 3D sketch. So click on that, delete this line, add in a new one, and I'll make it a construction line over here. So just that at least I know. Oh, hello? It's not what I wanted. Why? Why? Oh. All right, maybe not. Let's just undo this and get out of here. All right, so what we'll do instead is we'll just manually trim that out. So let's go in, cut away just a good chunk of this tube here. Just to ballpark it. All right, so features, extruded cut. If you remember when we cut stuff, we can pick which bodies we want to cut through. We'll pick that one, do all both. Just cut that body away. And I just want to keep this body here. Okay, cool. So now we have this cut tube, doesn't quite get all the way to there. That trim extend feature goes up to there. Allow extension. It's not trim check completely. This one. That's really weird. Maybe that's not quite the best example, but it's basically the trim extend is just for those kind of node treatments here. Sometimes the tube won't quite reach all the way, and so you'll use the trim extend. It'll automatically extend up to there. Probably just doesn't like that I took a big chunk out of that, but just was trying to give you guys a good example of kind of where it extends out. But again, the trim extend feature is there for that. And then we have just these kind of finishing pieces here. We can add them in if we want to, but they're not super important. So this end cap, if I were to go in here, and then I wanted to cap this end of this tube here with like a little piece of sheet metal or something like that, I will go ahead. Let's say it's like 1/8 inch sheet metal, so 0.125. Zoom into that bit there. You can see it gives me a couple of options for either cutting or just putting a cap on the outside of it, on the inside edge, or kind of an internal cap. And then you have this little gap here, your offset value. It's based on the thickness, so right now it's like half of the thickness is what it's offsetting. If I go back outside cap, you can see it's offsetting half of the thickness in, just to give me, again, some room to weld, to lay a weld bead down onto there. I can also just manually add that in. But yes, there's that thickness ratio. Inside, we'll kind of drop the cap inside of there. We'll also trim your tube away, so it kind of leaves room for that cap to sit and kind of still be flush with this face before. Not quite what we would want here necessarily, but kind of one of those finishing tools, features that we can add. Also add gussets in between them. I think we could do it between a round and we do need to add, so this would need to be between like a square piece and a square piece, and it would kind of go along this face here. But kind of looking at this gusset feature, you have this polygon kind of gusset where you can add in, you have these two kind of the legs of the gusset and kind of the distance away before it chamfers, or it's a simple triangular one. And you just fill in how it gussets in. The thickness, kind of where it thickens to, where it's located, kind of the middle, the edge of the profiles. You can offset it as well. But again, in SolidWorks, using these simple or kind of constant profile sections that we have and design a lot of in engineering, and simplifying the process of designing those for us by just giving us these tools. We make a lot of gussets. We don't want to go in and make a sketch every single time, constrain it to the tubes, all that kind of stuff. It's much easier to just go in and just click, gusset's done, based on a certain couple of inches, and it locates it along the tube right where I want it, and then it shows up in my bill of materials. Right, so that's almost it. The last thing that we have to talk about is the bill of materials for a Weldments. So if you remember when we were talking about assemblies, the bill of materials that shows us each individual part. For when we have a weldment part, we actually have something similar to a bill of materials. It's called a cut list. So it gives us all of the different tubes that we have. In this case, we have two of the same tube that we're cutting out here, so it groups them together for us. If I didn't take that big chunk out of there, just delete that real quick. Delete that sketch as well. Actually, those two are still going to be different just because of the miter cut or the cuts up here. But each of these tubes is individually given to us. And then when we go, I'll actually just pull up my roll cage because that'll be a good example. We go and create an actual bill of materials. Looking at this last week, gives us the lengths of the tubes that we start out with. So even for something complicated like this roll hoop, it gives us the length kind of as it goes up, over, through all the bends. And so when I go to cut my tube out and bend it up, I just cut to basically 103 inches, and I know that I'm going to have enough tube to make all those bends in my tube bender. I don't have to kind of bend the tube up and then fit it up and then kind of figure out how much I have left over. And then it also drops in on my cut list. These are sheet metal parts, which we haven't talked about. And I don't think we'll get to talk about this term. So we don't do hardly any sheet metal design in the team. But if we had like a gusset, which is basically a sheet metal part, or a end cap, also pops up here in our cut list. Gives us 4 or 2 or however many end caps, gussets, whatever other piece we make. But I think that pretty much covers weldments. Just open up this part here so you guys can kind of see. Yeah, again, same kind of corner treatments that we were doing before. If I isolate this part, kind of see it joins up to that tube there, joins up to another tube there. kind of for these more complicated ones up at the top, they actually go and interact with all of those different tubes coming into the node. But yeah, that's I think all we have for weldments. So let's go ahead and take a short, like 3-minute break, get some water, stretch your legs out or whatever else, and then we'll go into surfacing after that. All right, let's get back into it. So surfacing now. So surfacing is kind of an interesting concept to grasp. Basically, the way to think about it is every single part that gets designed in SolidWorks, when it's a solid body, which is mostly what we've been working on so far, is actually a combination of a bunch of surfaces. And SolidWorks is just doing a lot of the work behind the scenes to kind of streamline things. And with surfacing, the trade-off that you get is basically, do I do solid modeled parts with extruded bosses, bases, revolves, and kind of let SolidWorks do some of the control for the surfaces that are needed to create that, or do I go in and have finite control over every single surface within my part? So just to kind of illustrate that, we'll make a super simple. This is a common example that they use a bunch in all these surfacing examples. Just going to make a cylinder. I'll make a cylinder here, 120 millimeter diameter, for example. And then with my extrude, I go through and actually make this. I'll make it do 150 millimeters up. Cool. So one feature, 3 faces now, so 3 surfaces actually. So top, middle, and a bottom surface. And I let SolidWorks do all the work for me. I just gave it the 2 dimensions that I cared most about, didn't care about the finite control of all those individual surfaces, and it's all contained in one feature. Kind of same thing if I were to do like a cube or any other kind of basic shape. But if I delete this feature, and I want to make this same part with surfacing, I'm going to hop over here to my Surfaces tab, See, I kind of have the same, similar kinds of commands here. I'm going to start with an extruded surface, just using this sketch, 150 millimeters up. So there's my main kind of outside edge. Now I need a surface on the top, planar surface there, and a planar surface at the bottom. And what I've actually done now is created 3 separate surface bodies. So each of these is 0 thickness. If I cut through this part like that with a section view, you can see this part has no thickness. It's just those paper thin surfaces outlining the outside edge of my cylinder. Exit out of that. Now to make this an actual part, I have to knit the surfaces together. So kind of click on all 3 of them. It's going to stitch them together, kind of glue the edges. Now I have this option to create a solid, so that'll actually fill everything in. And now I have my cylinder. So when I go through and cut through it now, see it's solid all the way through. There we go, completely solid. So to create the same cylinder, this way it took us 4 steps, so 1 for each of the planes, or 1 for each of the surfaces, and then a knit at the end, combine everything together, and fill in the surface, or to fill in the volume on the inside with actual mass, actual material in there. So the advantage to using surfaces, again, is you have control. Every single one of these surfaces, I can control where it starts, where it ends, where it goes. It's not just sketch that gets SolidWorks automatically draws out. And that kind of, for simple stuff like this, doesn't need to happen. But again, kind of for that steering wheel example that I brought up earlier, in my, let's see if I can find it here. Might take a minute to load. Cool. Crashed it. I think it's because I wasn't on the, let's see, VMS. Yeah, that's why. It's because I wasn't on the VPN here, so let me just go through. Actually, we'll just go ahead and create a new file from scratch. Start SolidWorks. Kind of make something a little bit more interesting. Maybe we'll just try and make that steering wheel from scratch again and go through all the different surfaces. There we go. Cool, new part. So working with surfaces, the big thing that I want to stress is that very rarely are you ever going to create a part entirely with surfacing. There's almost nothing that you could ever conceive of that needs to be designed solely with surfaces. Usually what you're going to do is you're going to start with a solid body that kind of defines your simple parts. If we're starting with the cylindrical shape, we'll just make that cylinder first and then add in the extra stuff. And then we'll go from there. And so we don't have to, we're not always going to be doing everything that we, with surfaces. So we'll start with, just to keep things simple, we're just going to design the grips on our steering wheel here. So kind of do a simple, construction line to start, and then, because the center of the steering wheel is a fairly simple shape. There's where my first grips kind of come out to. I'll just make it super simple here. Just gonna have 2 grips. Right. So that'll be clear with that. I think the steering wheel that I designed was like 200, maybe 180 millimeters tall. I'm gonna add in another construction line here real quick too, from the midpoint there. Horizontal. These 2 bits equal at 30 millimeters. And then this will go out about 80. Just adding in some dimensions just to make everything consistent. And cool. And then I'll mirror everything over. All right, easy. Cool. From here, I will go ahead and just do an extrude boss from sketch plane. Not a thin feature. That's why. It's these 2 points. There we go. All right, so now I can extrude this feature out. Start with a 30 millimeter mid-plane extrusion. All right, and so now, I want to start defining kind of where, probably where my driver's palm is going to rest. So it's probably going to be along this area here. We'll make a sketch. Instead of, I'll actually go ahead and just create a plane off of this. Let's see, reference geometry plane on there. 0 millimeters, just so that we can always work off of this plane. So that's the top feature. Create a sketch, add in, I'll kind of just make it some like arbitrarily defined spline here. There. Cool. Actually, yeah, we'll just do that to start. In the middle here, I want this to come out kind of at an angle. I'll making it, adding a construction line that's horizontal. It goes out to there. Make this spline tangent to that. There we go. Cool. And then I'll just add in just some other features to define. Just, again, arbitrarily kind of putting out a little surface where my driver's palm is going to rest. Up here, there's some room for their thumb to kind of drop down in and exit out the sketch. Create a surface here. Start with a planar surface and just a flat little piece floating out in midair. Cool. Now I've defined one part. All right, now I want to create, let's see, I want to create the outside edge of the grip. So I'll make a sketch this time on the top plane, because for the steering wheel, we're going to just have a constant thing going all the way around. We'll just make a line there. Oh, that line shouldn't have been there. Another line there. Put those two out of the way. Make these equal. I'm going to drag them out to like here, and then put, if you remember, one of the things with the steering wheel is that the outside diameter is kind of what defines it. So what I want to do is make this arc centered at the origin, and then I'm going to give it some value. And this is going to be my outside diameter. It's going to be 160 millimeters in diameter for our steering wheel. That's what's important, because as I spin it around, I want to make sure that I have clearance for the driver's legs. And kind of that outside edge being an arc is what's important here. So I'll exit out of this sketch, and then I will create an extruded surface from that. See, it's just making that outside edge of the steering wheel. And then a mid-plane, 20 millimeters. So I don't actually want to go all the way up, because I'm going to fill in kind of some other things there later on. And so this is just the main outside edge. Cool. Another surface body. And now I want to connect these two together. So I have a couple of different options for connecting different surfaces. One of them is, I have lofts, we have sweeps like we had before. The boundary is one that I use a fair amount. So boundary, we just pick one edge and the other edge. Should probably flip these around so you can see kind of that is trying to line up those two. And what I'll do, right click and flip connectors. So that way it's going between those two now. And one of the things that's a good idea to do with surfacing is to kind of start small. Underdefine your surfaces, so just start kind of in the small section and then work your way out to the larger part. Usually what I would do for even more control is I could split up this outside surface into several subsurfaces, so that I know these points are, I know where those points are. But just for the sake of demonstration here, we'll just kind of draw it out to there. All right, and now just gotta move these out of the way so I can see them individually. I have options for how this surface is going to blend into the other one. So I can do tangency, curvature, I can do none. None is what it's selected with right now. We're just kind of drawing straight lines down. So what I want is for this to actually be tangent. I want this to kind of have some influence on how the surface is going to be made. You know, kind of going out here. Same thing here, tangency as well. Actually, probably even go curvature because this face is curved. And now it's going to blend that surface in with the other ones. You can see here, curvature from the top view blends in, goes up and over, ends up being tangent to there. So that's the boundary surface. Filled surface we use when we actually have like a full perimeter that we want to go through and kind of fill in nice and smooth. So we'll get to that one here in a little bit, but we're going to start working up to it. So we're going to kind of close in this section here, and then we're going to fill it in later. So one thing with surfaces that I can do, just like I can with other parts, is I can fillet stuff. So I can go through, add in a 10mm fillet. What it does is within that surface, smooths it out. And again, we're creating zero thickness geometry. So just push that in. Then I can go, I kind of want to make probably another planar surface that goes between these two. Actually, what I want to do, should have done this initially, but I want to actually fillet. Where is it at? There it is, right in front of me. I want to fillet these edges as well here. We're going to be working with them later on. Yeah, 5 millimeters. Cool. So there we go. Create a new sketch up here on this plane. Creating a sketch, going between this and this, make those two tangent, and same thing here. If you remember, we can add relations to stuff that isn't in our sketch, so I'm just using that surface edge and this edge on this body as well. Same thing with this other spline I'm going to add in. Starting out there, make that tangent. This tangent as well. Cool. And actually I'm going to make this less make that tangency less important, make that spline handle drive this curvature less, and make this one bend a little bit more. Alright, and then of course I want to fill this in with a line there and a line there. So now I have the shaded profile that I can use for a planar sketch. Or planar surface, sorry. And I guess kind of just to give a little bit more background, the planar surface is kind of just like a plane that's outlined by your sketch. So we got that there. And now I can start to think about filling this area in. So I'd probably go through and add in maybe another boundary surface if I wanted some more control here over, kind of subdivide. But we're actually just going to try and fill in this whole area all with one feature. And that is this filled surface. So it asks for a patch boundary. So we're actually trying to fill in the whole area, and it needs a kind of consistent, something that goes all the way along. So we'll start with that arc there, this bit here, there, and there. Just gonna think for a little bit and try and calculate. There we go. So it's kind of taking, the reason it took so long there is because I had to take this line and subdivide it. So what I'd actually probably want to do before I do this, so you can see this surface here has an edge that goes all the way down there. What I can do is I can combine these surfaces together. And this is something that you want to do periodically as you're modeling stuff with surfaces, is combine them all together so they're one surface. And now you can see that this edge just stops right there. And actually something that you could do, so it's kind of hard to see right now, and this is something that I've seen a lot of instructors do. So when you're looking at it, there's a little blue there, kind of on those open edges of your surface. You can make it pop out a little bit more in your system options, in your colors. Scroll down to, I think it's in surfaces, open edges. There we go. Edit that. Make it something that stands out a little bit more. Cool. So now that stands out a little bit better. I can see where my open edges of my surface are. If I suppress this feature, you can kind of see there's all those open edges all the way along. If I unsuppress this feature, these edges get closed off because it's all one surface now. It's all going along through there. Now I got my open edges. All right, so filled surface, back to that. Select all those lines, those open edges. Cool, gets my boundary a little bit quicker that time. And now I have settings for every single one of these edges on what kind of curvature I want to add to this. So this is where surfacing gets really, really powerful. You can, for each of these right now, it's just contact. So only guideline for this surface is that it has to touch all of these edges. But I can go through, and for each of these edges, for this one, I just want it to be tangent. This one, also just want it to be tangent. For this third one, because this surface isn't just a flat piece or constant curvature, it has varying curvature across the part. I want to carry that curvature through. And then for this next edge, and fairly simple edge, so I'll just do tangent. Same with this one, constant curvature, it has that constant radius. Add that in, and same thing there. Cool, so now we have the surface. Once I click the green check mark there, it gives me this nice, filled, smooth surface. And one of the things that you'll use a lot with surfacing is you want to kind of evaluate your curvature as you go. So you have a couple of different tools. This curvature tool is one of the better ones, or one of the kind of the visual ones that I like to use. So anything with black has zero curvature. You can think of this as a flat piece. Anything with a solid color all the way along it is a constant curvature. So this has a curvature that's defined by the radius that we set in our sketch, the diameter of the wheel as we're going through, making sure we have clearance for the driver. And then you can see kind of off to the side of my curvature, it gives me the curvature value itself as well as the radius of curvature. So 160 millimeter radius of curvature there. And then as we go through, you can see our radius of curvature going all the way along. And then if you remember when we had that curvature continuous along this, we actually said, all right, cool, we want to carry through the curvature from this edge all the way through to here. But if you look down here at the tangent, it doesn't actually carry that curvature through. So right at the edge, its curvature or it has that same kind of direction vector, you can think of it that way. So it's pointed in the same direction, but this radius of curvature is completely different and something that you'll be able to feel. Kind of the easiest way to think about it is, we have this tangent thing here. It's flat, and then it goes to curvature. So if you're designing things for kind of organic shapes, stuff that somebody's going to hold, one of the big things that's important is to make sure that you have a smooth curvature across your entire part, because the user, they want to feel just one smooth object. They don't want to feel sometimes all the different edges and places where it switches from a more flat to a more curved surface. Kind of the mouse is a good example. Even though this is flat and this is curved, there's a nice smooth transition all the way across. There's curvature along the entire part, and the curvature gradient isn't choppy. It doesn't go from zero curvature suddenly to a radius of curvature of 160 or something like that. On some edges it does, but for the most part, kind of when you're holding something, it's going to be curvature continuous. All right, so that's kind of most of the surface functions. Kind of extrude, revolve works the same way. It's just you're not creating, you're not filling in that area inside. You're just kind of extruding constant cross section or revolving a constant cross section. Swept surface, kind of like we were talking about last week and the week before, just creating that thin feature. We were thinking about the kind of piping, making that, except instead of actually having thickness on that, you just have the outside edge. Loft surface, same as a loft. Boundary is the one that we were using here. Kind of you can set what you're going between, and you can kind of drag those handles around to make it a smaller or a larger surface as well. So you have a little bit of flexibility there. And then filled surface, you need a full enclosed area to kind of to go between to add that all in. And then you do, this freeform thing is here. So it's something that SolidWorks added in fairly recently. You can just kind of move stuff around and drag it around. It's fun to play with, but it's very hard to actually get meaningful kind of design from. If you're just kind of creating concept models, that might be a good thing to kind of, all right, I kind of want the steering wheel to look like this and the surfaces to kind of look like that in the thumb area, but you're not defining any of that stuff. Then planar offset is a good one, and then kind of delete faces here. So we're going to talk about these here in a sec. But ruled surface, this is one that I don't use very often. but it can be fairly useful. Got to think of a good example here for a second. But yeah, so the knit surface is the other main thing that we want to keep in mind. As we go through, we want to combine our surfaces together, make them one surface body. So you'll see we have solid bodies. That's that main section that we created initially. Let me just get rid of this curvature showing. There we go. So that main solid body we created initially, and now we have just this one surface body that we're working with and slowly building it up to fill out the rest of the steering wheel. You can see all those open edges. They're all just along the outside edge. There's no open edges in the middle of the part. It means we have a good knit. It's just that outside edge that we're slowly working through. Cool. So one thing that I did want to touch on is how to convert from solid bodies to surface bodies. So if you remember, not always going to be working starting from the ground with the surface body. Sometimes we might build up something as a solid and then want to work with that as a surface. So a good example is this. We don't want this mass in the middle here. We actually want to open up these edges so that when we finish up kind of this grip surface, we can merge it into that. So we can do that with just the delete face command. So just click on the faces that we want to delete. Boom. And now we have this open part. So it takes that solid body, gets rid of all the mass on the inside, and opens up those edges. You can kind of think of it as a shell where your shell thickness is 0. So just the outside edge of the part gets left. And you just get rid of all those faces that you didn't want. So now we have 2 surface bodies and 0 solid bodies. So the solid bodies folder disappeared because we don't have anything in it. But yeah, now we can, once we, assuming we'd finish this up, we can merge it into there and kind of create one big surface body and then add thickness to it. Like for the carbon fiber part, we don't just have to, when we knit the surface together, we don't have to necessarily create that volume inside. What we can actually do is do a thicken. So like for this, I'll just do this as an example, thickening outwards, 2 millimeters. Don't merge the result. Cool. And now we have a solid body again. And basically just took that surface, thickened it out. So that's one of the ways that you can kind of have your surface workflow. That's what I did with the steering wheel. Created the outside, thickened inwards for however thick the carbon fiber was going to be, and then I could kind of figure out the mass of it and everything else. Or start creating the manufacturing plans for it and how to lay it up and everything else. Yeah.
Is there any way to thicken it at an angle? So like if it was inlaid in the part like the steering wheel, like we talked about it like in the second.
Talking about like a draft angle?
Yeah.
So I think just go through. Yeah, so you can't necessarily go through and add in the draft here, but you can. There is like a draft feature that we can go through and actually add draft to a part based on a particular part. Yeah, so when it thickens, it just takes the normal to that surface and just kind of thickens in that direction. And then if you need to add that in later on, you can. What I would do is if I know that this is going to be laid into a mold, I would just design a draft into the surface already, so I don't have to go in and add it in later on. Cool. So there's that. So again, we can kind of work between solid and surface bodies through those operations, the delete face being the main one that we use to convert to a surface. There it is. Cool. So yeah, delete face being the main one. Replace face is kind of another... It's kind of one of the rare ones. Basically, if I had another face that I added in kind of up here, I could kind of swap this face out for it. Kind of if I designed another face that had some more curvature, I could replace it in or something else. Replace this flat face with it. And then extending and trimming surfaces, that's another thing we can do. So let's say that I want to extend this bit out here, just arbitrarily. Instead of going and creating a sketch, I can just click on that surface. It follows the same curvature, goes out a certain distance, and I can do multiple edges at the same time as well. Just extend that out. Boom. And it doesn't create a new surface here. It just actually takes that edge or takes that surface and drags it out. So depending on if you actually want control over this extension later on or not, you might want to create either just an an extended surface or just going in and creating an extruded surface off of a plane there and converting those edges. Let's see, what else are we covering? I guess the only other one that we should cover is the offset surface. So sometimes you have to use several surfaces or a surface several times to create different kinds of geometry. And kind of, if I had my steering wheel model on, download it onto my laptop, I could pull it up. But offset surface, I can go through and just offset this to a certain dimension. If I had, I guess I could translate that surface to the bottom of the part. There we go. So yeah, like if I wanted this, if I didn't model this back face and I just wanted to translate that over, I can move it down 30 millimeters, and now it has that same exact geometry. But also what I can do is if I set this to 0 millimeters, it turns into a copy surface command. So again, if I need to make some kind of modification to it, it's kind of hard to give a use case, but just know that this part exists there. Or I guess a good example would be like if I had two parts butting up against each other, and just copy that surface over, start designing this section of the part, the left side, and then maybe the right side with the other surface, and then combine them together at the end. But now I can see that there's two surface bodies. There's that one. Oh, it didn't actually go through an offset surface. There we go. 0. Cool. So now I have one surface there, another big surface, and then a third surface. Yeah, so I think that's mostly everything that I had to cover. Again, surfacing is fairly complex. Just wanted to introduce you guys to it and let you know that you can kind of work between solid and kind of thin features. The bodywork, if you're doing stuff on chassis, is going to be something that should probably use surfacing. So I can kind of help out more with that and give some more guidance once we get to that point. But those are kind of the main things. You're going to start off with something simple, probably as a solid body, then kind of create some lines or some surfaces in midair that you start to define. Like the hood might be a surface that you start with, just that flat plane across the very top. Create some other curves that you go in between. I guess one thing that I should mention here, so I think when we I made this planar surface, right? So if I delete that surface, I don't want to delete it. There it is. Cool. So I can actually go through and make, if I go into the sketch again, delete these lines. So remember with that planar surface, I had to actually have an enclosed boundary that I worked with. Here I don't. I can just work, sometimes in surfaces I'll just have these random curves floating around in midair. And if I wanted to create that filled surface that we did before, let's see if it'll rebuild nicely. Probably won't. I'll have to go through and create some of this stuff again. We'll knit that together. Talk about the delete face. Yeah, so now I can add in a filled surface here. I can just do these arbitrary sketch entities. And right now it's actually trying to select the whole sketch. So that's not what we want. I'm going to delete that. One thing that I should mention is their selection manager, which I think, why isn't that letting me add in? That's really weird. Give me just a second here. I'm trying to figure out. Filled surface. Boom. Contour selection, maybe. That's weird. Either they changed this up or I'm thinking of something else. But basically, I can just select individual sketch entities instead of selecting the whole thing. In the past, what I'm thinking of is a selection manager thing that you can use to select. You can choose to either select several edges together and treat them all as one line, or you can select a face, and it kind of lets you filter through what you're actually trying to select. And then I can end select contours, I guess. But that allows me to, instead of selecting the whole sketch, just select that one line. And then I can go through, again, do the same stuff that I was doing before. 2, 3, 4, 5. Cool. Battery is open. What am I missing? 4, 3, 2, contour. 1. Weird. All right. Yeah. So you have the option to select other things. You don't have to select the whole sketch when you're making your filled feature or your filled surfaces or other, like your boundary surface as well is a good one for that. If I went through, I think it's going to give me the same thing. Or no, actually, it's just going to give me the sketch itself. Oh yeah. So here's the selection manager here that we're talking about. This is kind of what it looks like. Open loops, closed loops, groups of parts. So actually what I wanted to do is just click that, boom, and then there. Cool. So that's kind of how it works. Again, to kind of go a little bit more in depth into that real quick. Selection manager gives you the option to either select just a bunch of different items and treat them all together as one line or whatever else. It gives you the option to select an open loop. So go back into that. Clear selections. Selection manager. Pop that back up. Open loop. So it's going to go through and maybe it's going to treat this as a closed loop. Yeah, because that goes all the way around. That's our closed loop. We don't have an open loop because all this stuff kind of goes all the way around. If I just had like just this one edge or something like that floating around that didn't go all the way around the part, I can do that for an open loop. Multiple or like the select group feature is one of the ones that I use very often. I'll have like 3 lines or something like that I want to select individually but treat them all as one. So you can see open group here. That's kind of what it pops up as. And then the other option is this region. So that's kind of like a big kind of open area, kind of like a sketch area or something like that. Or just standard selection where you're just picking one thing at a time. I think that's everything there is to surfacing. And surfacing is fairly complicated, rarely used on the team, but more so I think than sheet metal. I just wanted to introduce you guys to a different way of thinking of parts. You guys have any questions about surfacing itself?
Not that I.
Okay. I guess one quick thing that I wanted to show that was kind of cool. An example that got shown to me a while ago. So I'm going to bring up that, create that cylinder again real quick. And it kind of, just to show you what SolidWorks is doing behind the scenes. Let's make that coincident. 120 millimeters, just a ballpark. Extrude it out, 150. Cool. So when SolidWorks is making these, remember we're talking about this is SolidWorks is doing surfacing behind the scenes regardless. One of the cool ways to see it is by the way that it creates a cylinder for us. So surfaces, we can go in and there's this untrim surface I think somewhere. Oh no, it's not gonna let me. Okay, so I'm offset surface. Do this to make a copy of it. See if it lets me untrim it. There we go. So what I did was I just untrimmed that surface, and this kind of shows you what SolidWorks is doing behind the scenes. So anytime that it's creating a surface, it's starting out with actually something rectangular, and then it's trimming it down to that circle shape. And one thing that it's trying to avoid doing is kind of create a singularity, if that makes sense. So if I think of this as like a 2D or like a I guess I'll try and add in the face curves here. Sketch. Surfaces. Probably gotta be up in here. Face curves. Cool. So this is kind of what SolidWorks is trying to do with its surfaces. It's actually subdividing into different lines. And I can almost do that. I can probably do the same thing on the bottom here. Let's see. There we go. Cool. So SolidWorks is starting out with a surface that is rectangular in nature and trimming it to fit something together. What I don't want to do is see a bunch of these. If I'm trying to analyze why a part's failing, sometimes I'll see all these face curves going to one point. And basically what SolidWorks does is in between each of these face curves, I'm arbitrarily adding in these face curves here now. But SolidWorks adds in a certain amount of face curves. For a basic planar surface, it's going to be just 2. It's 1 on each side to kind of outline a rectangle. But for like a more complex one, there will be more. And it's going to evaluate the curvature in between and kind of interpolate it. So if I had this really complex, bumpy surface, it's going between that face curve, kind of making a spline to the next face curve, to the other one, and so on and so forth. If all these lines come to a point in the middle, it's going to try and evaluate a spline between 2 points that are right on top of each other. It's going to start to kind of create these really close to each other, and the spline is going to just like shoot up this random bit that goes to the sky or wherever else. So that's something to kind of keep in mind. Kind of cool what SolidWorks is doing behind the scenes, but also kind of something to watch out for when you're making your parts. Kind of do this analysis sometimes. If you're going through the face curves command, it's kind of hidden, so not a lot of people know about it. You can go through, click on your part. See if we still have that steering wheel open. We don't. Okay. So yeah, you can go through, you click on your face curves, you can actually see where SolidWorks is interpolating between for those surfaces, and go from there and kind of say, oh yeah, this is all coming to a point here. I should kind of cut that area out and remake it so it's a little bit nicer, and SolidWorks fits a nice surface into it rather than trying to kind of go get cornered in. I don't know if that really made a lot of sense, but that's kind of where we're at. So again, surfacing, complex, use it sometimes, interchange it with your solid modeling techniques. As we go, if somebody ends up designing the bodywork for their car, I'll probably help out a little bit more, and we can use that as a case study for everybody to learn from. But yeah, the hard part with surfacing is it takes a lot of time. You have a lot of control over every single surface, so you're going through and trying to control it and define it and make it exactly the way that you want it. One of the frustrating things when I was designing my steering wheel was every time that I designed every time I made a design change, it would break like 3 or 4 of the other surfaces, and so I had to go through and re-add in, redefine them. Kind of, if you remember that outside edge that I made, it was one surface. I had to go in and split up, into different surfaces. I can control the points where that boundary surface was being defined from and stuff like that. So definitely is an iterative, long process, but it's one that gives you a lot of control and makes a lot of really nice, neat, organic shapes and good-looking shapes. Exteriors of cars are pretty much 100% surfacing, at least in the modern day, with all those nice curves. Maybe when Volvo was designing it, they're just using extruded bosses and bases, but yeah. You guys have any questions before we finish up for today? Cool. All right, next week we're doing design intent. So we'll kind of talk about, again, take a step back from SolidWorks, kind of think about more high-level stuff, and then look at some of the tools within SolidWorks that help us communicate our design intent and kind of work with other parts and with other teams more effectively. But if you want, something to practice during the week, mess around with surfaces. Just hop in, try to create some basic shapes like a cylinder, a square, or a square box. Something a little bit more complicated, like a vase or like a piping system or something like that. And then, if you want to try and tackle a steering wheel, you can, or something, or maybe, download the chassis from 2019, try and see if you can make a bodywork for it. Start out some sketches where you're going to have those defined lines coming through and those planar surfaces, and start to mess around with that. It does take a while to pick up on it, so if you want practice, it is out there to help you out if you guys drop by the lab when I'm there. But yeah, that's all I have for this week, and I'll see you all next week.